Crawler excavator. The crawler excavator is the machine most people imagine when they hear the word excavator. Instead of traveling on wheels, it moves on two continuous steel tracks that spread the machine's weight across a much larger surface. This simple design gives it remarkable stability and allows it to work on muddy ground, loose soil, rocky terrain, and uneven landscapes where wheeled machines would struggle to maintain traction. The earliest excavators were powered by steam and cables, but modern crawler excavators became practical after hydraulic technology transformed the construction industry during the middle of the 20th century. Hydraulic cylinders gave operators precise control over the boom, arm, and bucket, making excavation faster, safer, and far more efficient. Today, crawler excavators are found on almost every major construction site around the world. One of the biggest strengths of a crawler excavator is its ability to handle demanding jobs. The tracks create a stable base that allows the machine to dig deep trenches, lift heavy material, and work on steep slopes without easily losing balance. Even when the boom is fully extended with a heavy load, the wide track system helps distribute the forces evenly across the ground. The machine is not built for speed. Most crawler excavators move at only a few kilometers per hour, making long-distance travel impractical. Instead, contractors usually transport them between projects on heavy-duty trailers. Although this adds transportation costs, the superior stability and digging power more than make up for it once the machine reaches the job site. Modern crawler excavators are also incredibly versatile. Their hydraulic systems allow operators to replace the standard bucket with attachments such as rock breakers, demolition shears, grapples, compactors, augers, and hydraulic thumb. A single machine can therefore perform excavation, demolition, material handling, foundation work, and even forestry operations simply by changing its attachment. Because of their strength and adaptability, crawler excavators remain the backbone of the construction industry. Whether building highways, digging foundations for skyscrapers, clearing land, or working in mines, they continue to be the first choice whenever maximum stability and digging power are required. Wheeled excavator. The wheeled excavator performs many of the same tasks as a crawler excavator, but it approaches those tasks very differently. Instead of steel track, it rides on large rubber tires that allow it to travel much faster across paved roads and developed areas. This mobility makes it especially valuable for projects where the machine needs to move frequently between nearby job sites. As cities expanded and infrastructure projects became more common, contractors needed excavators that could operate efficiently without damaging roads. Rubber tires solved that problem. Unlike steel tracks, they leave very little impact on asphalt and concrete, reducing repair costs while allowing the excavator to drive directly through urban streets. Although wheeled excavators offer excellent mobility, they do sacrifice some off-road capability. Soft mud, loose sand, and steep slopes are much better suited to tracked machines. To compensate for this limitation, most wheeled excavators are equipped with hydraulic outriggers or a front stabilizing blade. Before digging begins, these supports are lowered onto the ground to increase stability and reduce movement while the boom is operating. Many wheeled excavators can also travel at speeds several times faster than crawler models. This means an operator can finish work at one location, drive to another nearby project without waiting for transport equipment, and begin working again within a short period. That flexibility saves both time and operating costs. Like their track counterparts, wheeled excavators can use a wide range of hydraulic attachments. Buckets, grapples, breakers, lifting hooks, and compactors all allow the machine to perform different tasks throughout the workday. Because of this versatility, they are commonly used for road construction, utility installation, bridge maintenance, drainage projects, and municipal infrastructure work. For contractors working mainly in developed environments, the wheeled excavator provides an excellent balance between digging capability and transportation efficiency. It may not outperform a crawler excavator on rough terrain, but on paved surfaces, it often completes projects with greater speed and flexibility. Mini excavator. The mini excavator was developed for places where larger machines simply could not fit, usually weighing less than 6 metric tons. It combines the essential functions of a full-sized excavator with a compact design that allows it to work in tight and confined spaces. As residential neighborhoods became denser and renovation projects increased, construction crews needed equipment capable of operating inside backyards, narrow alleys, and between existing buildings. Full-sized excavators often required too much space to maneuver safely, creating demand for a smaller alternative that could still perform meaningful excavation work. Despite its size, a mini excavator includes nearly all the components found on larger machines. It has a rotating upper structure, a hydraulic hydraulic boom, an articulated arm, and a digging bucket mounted on compact tracks. Modern hydraulic systems provide surprisingly strong digging performance considering the machine's relatively light weight. Its greatest advantage is accessibility. A mini excavator can pass through narrow gates, work close to houses, and dig in areas where larger construction equipment would risk damaging nearby structure. This makes it especially useful for landscaping, residential foundation, drainage system, swimming pool excavation, utility repairs, and garden construction. Another important benefit is reduced ground pressure. Because mini excavators weigh much less than standard machines, they create less damage to lawns, sidewalks, and finished landscaping. Contractors often use rubber track pads to further protect delicate surfaces while maintaining traction. Like larger excavators, mini models support numerous hydraulic attachments. Operators can switch between buckets, augers, breakers, trenchers, and grapples depending on the task at hand. This versatility allows a single compact machine to replace several specialized pieces of equipment on smaller projects. The popularity of mini excavators has grown steadily over the past few decades. Today, they are one of the fastest growing categories of construction equipment because they offer an effective combination of precision, affordability, and versatility for contractors working in confined environments. Midi Excavator. The Midi Excavator occupies the middle ground between a compact mini excavator and a full-sized crawler excavator. It was created for contractors who needed greater digging power without moving all the way to the side, weight, and operating costs of larger machines, typically weighing between 6 and 10 metric tons. A midi excavator delivers noticeably higher hydraulic performance than a mini excavator. The larger frame supports a stronger boom, increased lifting capacity, and deeper digging depth, allowing it to tackle more demanding construction projects while still remaining relatively compact. This balance makes the machine particularly attractive for medium-sized commercial developments, road improvement projects, utility installation, drainage work, and foundation excavation. It provides enough power to handle substantial workloads while remaining small enough to access many locations that would be difficult for heavier excavators. Transporting a midi excavator is also generally easier than moving a large crawler excavator. Depending on local regulation, contractors may use smaller transport equipment, reducing both fuel consumption and logistics costs when moving between projects. Operators often appreciate the improved comfort as well. Because the machine is larger than a mini excavator, manufacturers can install more spacious cabs, better visibility, stronger climate control system, and advanced hydraulic controls that reduce fatigue during long working hours. The increased hydraulic capacity also expands the range of compatible attachments. Larger bucket, hydraulic breakers, compactors, grapples, and augers allow the machine to perform excavation, demolition, lifting, and material handling with greater efficiency than smaller compact models. For many construction companies, the Midi Excavator represents an ideal compromise. It combines much of the productivity of a standard excavator with the maneuverability and lower operating costs of compact equipment, making it one of the most practical choices for everyday construction work. Long-reach excavator. The long-reach excavator is designed for jobs that are simply beyond the reach of a standard machine. At first glance, the difference is immediately noticeable. Its boom and arm are dramatically longer, allowing the bucket to extend many meters farther than a conventional excavator. That extra reach makes it possible to dig, dredge, or demolish structures from a safe distance without constantly moving the machine. The concept emerged as construction projects became larger and more specialized. Engineers needed equipment capable of excavating deep canals, maintaining riverbanks, and working on slopes where placing a standard excavator would be difficult or dangerous. Rather than creating an entirely new machine, manufacturers extended the boom and arm while reinforcing key structural components to handle the additional forces. Because of the increased length, the machine sacrifices some lifting power. A long boom acts like a giant lever, meaning the farther the bucket reaches, the greater the stress placed on the excavator. To maintain stability, these machines often use heavier counterweights and carefully designed hydraulic systems that keep the machine balanced during operation. Long-reach excavators are commonly seen clearing sediment from rivers, lakes, and drainage canals. They also play an important role in coastal engineering, where they help reshape shorelines and maintain waterways without requiring workers or equipment to enter unstable ground. Another major application is demolition. Instead of placing workers close to unstable buildings, operators can safely remove upper floors, weakened walls, or damaged structures from a a greater distance. This improves safety while allowing demolition to progress in a controlled manner. Although they are highly specialized, long-reach excavators solve problems that standard machines cannot. Their ability to work across water, over steep embankments, or into deep excavation sites makes them an essential tool whenever distance becomes the greatest challenge. Compact Radius Excavator. The Compact Radius Excavator was created for construction sites where every meter of space matters. Unlike traditional excavator, whose counterweights swing well beyond the track during rotation, a compact radius machine keeps most of its rear body much closer to the undercarriage. This allows it to work in confined environments while still delivering the performance expected from a standard excavator. The demand for this design grew alongside urban development. As cities became more crowded, contractors increasingly worked between existing buildings, along narrow streets, and beside active traffic. In these situations, the wide rear swing of a conventional excavator could easily strike nearby obstacles, forcing operators to work more slowly and cautiously. Engineers addressed this problem by redesigning the upper structure and repositioning internal components. The engine, hydraulic pump, cooling systems, and counterweight were arranged more efficiently so that the machine could rotate within a much smaller footprint without sacrificing too much lifting performance. This design significantly improves productivity because operators spend less time repositioning the excavator. Instead of constantly checking rear clearance, they can focus more attention on the digging operation itself. That becomes especially valuable on busy construction sites where multiple machines and workers operate close together. Compact radius excavators are frequently used for utility installation, road widening, bridge repairs, pipeline construction, and commercial developments where available working space is extremely limited. They also reduce the need for traffic closures since the machine occupies less of the roadway while operating. Although they may appear only slightly different from standard excavator, the compact radius design represents an important evolution in construction equipment. It allows contractors to bring full-size excavation capability into places that were once considered too restricted for large machinery. Zero-tail swing excavator. The zero-tail swing excavator takes compact design one step further. When the upper structure rotates, no part of the machine extends beyond the width of its track. Everything remains inside its own footprint throughout the entire swing, making it one of the safest excavator designs for working in confined spaces. This concept was developed to meet the growing demands of urban construction. Contractors often needed to excavate beside buildings, retaining walls, fences, and active roads where even a small rear overhang could create a serious safety hazard. By eliminating that overhang entirely, manufacturers greatly reduced the risk of accidental collisions during operation. Achieving this design required careful engineering. Components that would normally occupy the rear of the machine had to be repositioned, while the counterweight was redesigned to maintain balance despite its reduced size. Engineers also refined the hydraulic system to preserve digging performance within these tighter design constraints. The greatest advantage is confidence. Operators can rotate continuously without worrying about striking nearby obstacles behind them. This makes the machine especially valuable for residential construction, indoor demolition, basement excavation, utility work, and maintenance projects where available space is measured in only a few meters. There are some trade-offs. Because the counterweight is smaller, lifting capacity may be slightly lower than that of a conventional excavator with similar operating weight. Even so, for many contractors, the improved maneuverability far outweighs the reduction in maximum lifting performance. Today, zero-tail swing excavators have become increasingly common in cities around the world. As construction continues to move into tighter spaces, their ability to combine safety, precision, and efficiency makes them one of the most practical excavator designs available. Amphibious Excavator. The amphibious excavator is built for places where ordinary excavators cannot survive. Instead of relying on standard tracks alone, it uses wide floating pontoons that spread the machine's weight over an even larger area. These pontoons allow it to travel across swamps, marshes, wetlands, shallow lakes, and waterlogged ground that would quickly trap conventional construction equipment. The need for amphibious excavators grew as governments and environmental agencies began managing waterways more actively. Maintaining rivers, restoring wetlands, preventing floods, and cleaning drainage systems often required heavy machinery to operate in locations where solid ground barely existed. Traditional excavators either became stuck or required expensive temporary platforms before work could even begin. The floating undercarriage allows the the machine to move safely across saturated soil while maintaining remarkable stability. In shallow water, the pontoons provide buoyancy, reducing ground pressure to a fraction of that produced by standard track excavators. Some models can even propel themselves through water using specially designed hydraulic track systems. Their work is incredibly diverse. Amphibious excavators dredge canal, remove accumulated sediment, restore natural waterway, clear invasive vegetation, construct flood control system, and assist in environmental conservation projects. In coastal regions, they are also used to strengthen shorelines and maintain navigation channels. Because these machines often operate in sensitive ecosystems, operators must work with exceptional precision. The excavator's long boom allows vegetation, debris, and sediment to be removed while minimizing unnecessary disturbance to the surrounding environment. This makes the machine valuable not only for construction, but also for ecological restoration projects. Although amphibious excavators are rarely seen on ordinary construction sites, they perform some of the industry's most challenging work. They extend the capabilities of excavation beyond dry land, allowing engineers to build, maintain, and protect landscapes where water and earth constantly meet.